Hello. I got one person here so far. Welcome, welcome. We'll probably wait 5 minutes. We didn't have much turn out last time. Let's wait like 5 minutes or so for people to join. Yes, while we're waiting, I will pull up an F or Q, I think. It's just an MCQ today. I want it a little more cleanly, if possible. Alright, that should be showing up soon. Okay, there we go. Yeah. A couple more minutes. Okay, let's about get started. Plan is to get through the multiple choice section. This is a 2013 international version of the AB test. Okay, let's start. A lot of initial stuff. Okay, this limit. You're supposed to factor. You can just cheat by L'Hopital's ruling, though. It's like 2x plus 1 over 2x. That's going to be 1. Oh, sorry, going to 2. What am I talking about? That's going to be 5 over 4. Okay, 2. F prime of 2, F prime of x is going to be, what's that, 3x squared minus 2x plus 1. Plug in 2, you get 3 times 4 minus 2 times 2 plus 1. You're going to get 12 minus 4 plus 1. That's 8 plus 1. That's 9. Okay, next one, 3. Which of the following integrals has the same value as that? They want a u sub. U is x squared. Du is going to be 2x dx. So it's going to equal 1/2 integral 0 to... So we're going to plug in x squared. So 0 to 16, I believe, of e to the u. The 1/2 comes out here, right? It's like if you solve for dx, you can get dx is, or rather x dx is du over 2. So this piece here can be subbed out with this piece there. X dx is a half du. Okay, so it's going to be that one, and that looks like B. Coolio. 4. Which of the following is an equation of the line tangent to the graph of whatever at the point 1, -3? Okay, tangent line. So we have dy dx, sorry, 2x minus, got to use chain rule here. This is, product rule. This is implicit differentiation. 3 times x dy dx plus y equals 0. So we got 2x minus 3x dy dx plus 3y is 0. Plug in the point 1, -3. Sometimes people try to solve for dy dx here. You can, but it's easier just plug in the point 1, -3. So 2 minus 3 times dy dx plus -9 is 0. Yeah, and so 2 minus 3 dy dx, oops, I'm going to do 9 would go over, 2 would come over, so that's going to be 7. So -3 dy dx equals 9 minus 2, 7 over -3, so 7, okay. So dy dx is -7/3. Looks like it has to be B. Why do I know it has to be B? Well, because that's the only one that's a tangent line with the right slope. This should be the slope of the tangent line. Okay, number 5. If g is a function given by whatever, when is g decreasing? G decreases when its derivative is negative. G prime of x is x squared plus 3x minus 70. That factors as x plus 10, x minus 7. When is that negative sign diagram? Has a root at -10 and 7. It's a positive quadratic, so it looks like plus minus plus. All right. And when is it negative? -10 to 7, d. 6. That integral, okay, this is going to be this is the same thing as the antiderivative is natural log of 5 minus 3x. You can use sub that, but this is kind of easier. And this will be negative ln, the negative is from a chain rule, negative ln of 5 minus 12 minus negative ln of 5 minus 6, which is negative ln, the absolute values come in handy here, negative ln 7 minus or plus ln of 1. ln of 1 is 0. It's negative ln of 7. 6, or 7. Let f be the function given by whatever. What is the instantaneous rate of change of f at x equals 3? Okay, instantaneous rate of change is just derivative. 3x squared minus 12x plus 8 at 3. F prime of 3 is 3 times 9 minus 12 times 3 plus 8. That is 27 minus 36 plus 8. That is -9 plus 8, which is -1. I think that works. I am going a little, that works. I'm going a little fast, so I might have mistakes, but we'll check. 8. A particle moves along a straight line. Cool. The graph of the particle's velocity is shown above. Okay. JK, LM are all labeled here conveniently. When is the speed decreasing? Okay, so speed decreasing is when velocity and acceleration are opposite signs. So let's see, speed decreasing. So that kind of looks like going inwards towards 0, like those two. So I would say J to K and L to M, right? Because the velocity is positive here and decreasing. So that's opposite. And then here the velocity is negative and increasing. Yeah. So J to K and L to M. C. 9. When is F not continuous? Oh, I hate this kind of question because it's a little bit silly, but Oh, they might get me on this one. So definitely not continuous at -1. And then it has a removable discontinuity at 2. Like the 2 cancels. Yeah, I'm going to go with D. I think that's what AP Calc would say. Although in higher math, you might not even call to a true discontinuity. Like, it's not even defined there. It's kind of weird to talk about being continuous at a place that's not defined, right? But I'm going to go with that. 10. A particle moves along the x-axis with velocity given by whatever. Okay, so this is an FTC one. This one can be tricky for a lot of students. You want to find x of 3. So x of 3 minus x of -2, sorry, x of 0, is the integral from 0 to 3 v of t dt. But we know x of 0, and we know v of t. So we get x of 3 equals 2 plus, move the 2 over, and then integral, that's t cubed minus 4t. 2 plus, let's see, that's going to be 27 minus 12, and then minus 0. 27 minus 12 is 15, that's 17. Okay. 11, let f be the function defined by, okay, some integral. When is f concave down? So f is concave down when f double prime is negative. F prime of x by FTC part 1 is just 2x squared, x cubed, minus 15x squared, plus 36x. And so f double prime, this is FTC, f double prime is 6x squared minus 30x plus 36. It's a 30. Okay, and we want to know when that is negative. So we've got to factor that. If 6 pulls out, that's x squared minus 5x plus 6, and that factors easily. Okay, sign diagram, because we want to know when it's negative. So we got 2 and 3. And it's a positive quadratic, so plus minus plus. Yeah, 2 to 3. Right. Okay, next one. Just checking the stream briefly. Okay. For which of the following does limit as you go to infinity equals 0? Okay. So this one definitely goes to 0. I mean, the bottom's getting like super duper large. Top's getting oops, I scrolled that wrong. Getting large, but not very quickly. I mean, you could L'Hopital's rule that, but it'll be 0. So it's this one. This one at a glance does not. E to the x blows up way faster than ln of x. And this one does. E to the x is faster than every polynomial in the entire universe. So if you take L'Hopital's rule 99 times on that, you will, I'll show you what I mean. If you take L'Hopital's, you get 99x to the 98 over e to the x, and then you get, 99 times 98 times x to the 97 over e to the x, and you just keep going. Because e to the x never changes. You go all the way down forever until you get to 0 over e to the x or something. Actually, so you go to like 99 factorial over e to the x, and that will, of course, go to 0. Right, one only. Sorry, 3 is correct. 1 and 3. Let f be differentiable. Okay, cool. What is not? This is a good one. Yeah, this is like an actual application of MVT. So the idea is that MVT says there is a point between 0 and 2 such that f prime of c equals f of 2 minus f of 0 over 2 minus 0, because it's differentiable, presumably everywhere, which is f of 2 is, we don't know, plus 5, right, minus -5 over 2. But then f prime of c needs to be less than 3. So we have f of 2 plus 5 over 2 needs to be less than or equal to 3. F of 2 plus 5 needs to be less than or equal to 6. F of 2 needs to be less than or equal to 1. Cool. So 1 is possible if it's a straight line, and then e is not possible. Let f be a function above. Okay, we want a and b, so it's differentiable at 1. Okay, the quick and dirty method here is just plug in. Well, it needs to be continuous. So plug in 1 and you get b on top and a on bottom, so a needs to be b. And then you take the derivative, you get 1 on top and 2a on bottom. So 2a needs to be 1, so a is a half. But I guess I goofed up. I plugged in 1, I said b. It's 1 plus b. A is 1 plus b. Silly me. A equals 1 plus b. So a is a half and b is 3 halves. That makes more sense. Yeah, if you kind of think about graphing this for a second, x plus 3 halves looks like this up to 1, and then you have a half times x squared. Let's admit doing this right. A is 1 plus b. God, no, I'm just not thinking at all. I was going to check. A is 1 plus b. A is a half, so a half is 1 plus b. Silly me. B is negative a half. God. Okay. A. I think that makes sense. When you think of the graph there. So you go up here and then a half x squared. That would be believable. Okay, that would be believable. Yeah, I like A. Okay. Next one, the table above gives values for functions f and g and their derivatives. Okay, oh, yeah, there you go. Quotient rule, very fun. I want k prime of 3. Well, we know k prime of 3 is going to be low d high, g of 3, f prime of 3, minus high d low, f of 3, g prime of 3, all over low squared, g of 3 squared. Okay, g of 3 is 2, f prime of 3 is 5, f of 3 is negative 1, g prime of 3 is negative 2, g of 3 squared is 4. That's 10, 3 negative, so minus 2 over 4 is 8 over 4, which is 2. Enjoying some tea right now. Okay. If y is 5x root x squared plus 1 dy dx at x equals 3 is... So basically this is a product and chain rule. So y prime is 5x times 1 over 2 root x squared plus 1 times 2x, and then plus 5 root x squared plus 1. And then you plug in 3. I guess I should explain that. That was a little complicated. So first 5x times derivative of the second, which requires a chain rule. 1 over 2 root x squared plus 1. Then you got to multiply by the derivative, 2x. And then plus the derivative of the first, which is just 5. And then times the second. Yep. Okay, now we plug in 3. 15, 1 over 2 root, I guess that's 9 plus 1, root 2 root 10, times 2 times 3, plus 5 times root 10. Okay, and that's going to be, let's see, 15 times 2 times 3, the 2's cancel, it's convenient. You get 45 over root 10 plus 5 root 10, I think that's D. Yep. Okay, 11, okay, this is just a definition of a derivative. So this is going to be equal to f prime of a, where f of a is arc sine, well, f of x is arc sine of x. So f prime of x, hard to remember, I know, negative 1, well, not negative, 1 over root 1 minus x squared. So f prime of, so this boils down to f prime of a, on one hand is 2, on the other hand is 1 over root 1 minus a squared. So we get 1 over root 1 minus a squared is 2, flip both sides, root 1 minus a squared is a half, square both sides, 1 minus a squared is a quarter, subtract both sides from 1, a squared is 3 quarters, and square root a is root 3 over 2, plus or minus. But one of those is not allowed. Negative 1's not allowed. I'm trying to think why the negative 1's not valid. Oh, this could be the value. That's kind of silly. Fine. B. if ln 2x plus y is x plus 1, okay, this is just implicit differentiation, just differentiate, you get 1 over 2x plus y, don't forget to chain rule, times 2 plus dy dx equals 1. And then you gotta solve, so multiply by 2x plus y, 2 plus dy dx, and divide. Not divide, when I'm talking about subtract, 2x plus y minus 2. Yep, B. Okay, 19. The figure above shows the graph of the function whatever, and the line tangent at -1. Let h be the function given by h of x equals e to the x times g of x. So it looks like a product rule. H prime of -1 is going to be, well, I'll say h prime of x. Product rule, so first e to the x times derivative of second g prime of x plus the derivative of the first e to the x times second g of x. Plug in -1, h prime of -1 is e to the -1 g prime of -1 plus e to the -1 g of -1. You can factor out that e to the -1 is 1 over e if you want. Okay, g prime of -1, the slope of this tangent line at -1, that's how you can figure that out. That looks like over 1 down 6. So that is -6. -6 plus, and then g of -1 is 3. So -3 over e. B. Okay. 20, that derivative, kind of crazy, but gotta remember your FTC part 1. You plug this in for t and this t as well. So ln of 2t, of 2x cubed plus 1 times 2. Everyone forgets the chain rule. ln, I want it simplified a little bit, 8x cubed plus 1 times 2. T. Okay. Next one, the graph of the function shown above. What's the value of 0 to 7? Integral 0 to 7. Okay, just add up some area, I guess. Yeah, because this is the area under the curve. This first piece is a trapezoid, average height of 3 halves, and by 2, so that's area 3. And then you have a rectangle here that's just 4 boxes, and then you have 1, and then you have -2. Okay, so that's going to be probably 6, huh? Yeah. Just double check my areas. Yeah, good to go. All right, 22, the function f is continuous for all real numbers, and the average rate of change in the closed interval is -3 halves. Looks like I set up to MVT. Oh, there we go. There's no value of c such that f prime of c is -3 halves. Like, if f were differentiable on the open interval 6 to 9, then it would be forced. So, oh, okay, there we go. Oh, that must be false. Okay. Okay, what are they talking about? Of the following. So, they're saying MVT doesn't hold, which is. Oh, sorry. Okay, yeah, E must be true. Sorry, I didn't see the word not. Yep. F is not differentiable on the open interval 6 to 9. That's kind of a weird phrase for that. I would say it's not the case that F is differentiable on 6 to 9. It kind of makes it sound like it's differentiable nowhere on 6 to 9. Yeah, the integral is completely irrelevant. This integral is irrelevant. That doesn't matter. Yeah, doesn't matter. Okay. 20. So I guess this is kind of confusing. This is an MVT problem. Basically, if E were true, then this last thing would be forced based on the initial thing. Let f be the function defined by whatever. If g is f inverse, okay, you gotta know the inverse function rule. So the rule is g prime of x is 1 over f prime of g of x. So g prime of 1 is going to be 1 over f prime of g of 1. Now they tell you the point 0, 1's on the graph. That means f of 0 is 1. That means g of 1 is 0. They usually will tell you this on these problems. 1 over f prime of g of 1 is 0. We got to find f prime. F prime of x is 2 plus e to the x. When you plug in 0, you get 3. So 1/3. There. 24, the function g is given by whatever. What is the absolute min? Okay, that's a candidate's test. So you gotta find the critical points. G prime of x equals 12x squared plus 6x minus 6. When is that 0? Factor it, pull out a 6, that's 2x squared plus x minus 1. Factor that again. That is, let's see, 2x minus 1, x plus 1, right? 2x, and yeah, that's right, okay. I want that to be 0 to find critical points. So that's going to be x is a half and x is negative 1, looks like. All right, so I got to check negative 2. Oh, this sucks. A half, negative, oh, sorry, for negative 1. Negative 1, a half, and 1. There is an easier way, though. Absolute min, you only need to check the local mins. These are 2 critical points, but if you make a sign diagram, you can get negative 1 and a half, and it's a positive quadratic, plus minus plus. This is increasing to decreasing. That's a maximum at negative 1, so I can ignore that one. Yeah. Okay, so I really only need these 3. Plug in negative 2. Oh boy, 4 times, I guess, yeah, if you like synthetic substitution, you can do it. I'm just going to plug it in. 4 negative 8 plus 3 times 4 minus 6 times negative 2 plus 1. That's negative 32 plus 12 again plus 1. That looks like negative 32 plus 25, which is negative 7. Well, based on the answers, that's got to be it, right? I mean, you plug in anything else, it's going to be, I mean, if anything else were the answer, I could just say negative 7 smaller, right? Well, let's do our due diligence and check the rest. Next one is 4 times an eighth plus 3 times a quarter. That's for a half. Minus 3 plus 1. Okay, that's a half plus 3 quarters minus 3 plus 1. Yeah, there's no way is that ever going to be close to negative 7. So I'll say greater than negative 7. And then you plug in 1 and you get 4 plus 3 minus 6 plus 1. That's also greater than negative 7. Yeah, it's negative 7. Okay, 25. Which of the following is a solution to the Diffie-Q with initial condition, whatever? All right. Sorry. Okay. All right, this one you got to break up as e to the y times e to the x. And so dy over e to the y equals, and really you should think of it as e to the negative y dy equals e to the x dx. That'd be a nice way of doing it. Integrate, you get negative e to the negative y equals e to the x plus c on bottom. And then you make it things negative. E to the negative y is negative e to the x plus c. And then you take the natural log. Negative y equals natural log of c minus e to the x. And then you make it negative. Y equals negative natural log of c minus e to the x. Cool. And then we plug in the initial condition. Negative ln of 4 equals negative ln of c minus e to the 0. That is negative ln of c minus 1. The negatives cancel, the ln's cancel. You get 4 equals c minus 1. C is 5, it seems. And that looks like c. Yeah. So I double check that one. Plug in 0. Yeah. Okay, 26. What is an antiderivative of square root 1 plus x cubed? Oh, this one's tricky. So you should kind of think like this doesn't actually have a very convenient antiderivative, so probably c, d, or e should be what you're looking at. Man, e looks incredibly straightforward. Yeah, it's e. This is more of a question of why the other ones not work. If you plug this in, right, like if you take the derivative of this, you should plug in and plug in there. You get root 1 plus x cubed. You might think that's good, but you got chain rule times 3x squared. That's no good. Kind of same issue for this one. And these just don't work. You can try them, but they don't. It's e. 27. For time t greater than 0, the height h of an object suspended from a spring is given by whatever. What is the average height? Okay, average height from 0 to 2. That's an average value thing. H average is 1 over 2 minus 0 times integral 0 to 2 of ht. That's 1/2 integral 0 to 2 of 16 plus 7 cosine pi t over 4 dt. Oh man, I have to do this by hand. That's so annoying. Okay, fine. 1/2 integral 0 to 2 of 16. Oh, sorry, anti-differentiate. 16t plus 7 sine pi t over 4 times 4 over pi, I believe. Yeah, they want you to U sub. I'm not gonna. Basically, just check in your head that like this does differentiate to that guy. The cosine pulls out, and you get a pi over 4. Yeah, that works. Okay, and then from 0 to 2. So 1/2 is times everything, of course. 1/2 times. Oh boy. Well, when you plug in 0, luckily you do get 0 because 16 times 0 is 0, and sine of 0 is 0. So it'll be 32 plus 7 sine. Well, it's going to be sine pi over 2, right? 2 pi over 4 pi over 2. That's 1. 7 times 4 over pi. Okay, that's going to be 1/2 times 32 plus 28 over pi, which is 16 plus 14 over pi. Looks like that guy. Yeah. If you're being clever, you might say, well, it's obviously 16 plus the average value of that, which it is. All right, 28. The function f is defined by whatever. What is the x-coordinate of the point of inflection? Okay. Oh, when it changed from concave down to concave up. That's important. That's extra information. All right, point of inflection. Oh, I need to look for this change from concave down to concave up. So f goes from concave down to concave up. That's going to be f double prime changing from negative to positive. So I want to make a sign diagram of f double prime. F prime of x is cosine of x minus sine of x. F double prime of x is negative sine of x minus cosine of x. Okay, when is that 0? This is when I like kind of rush through, I think, sometimes. Yeah, okay. So you would get really sine of x plus cosine of x equals 0. So you get sine of x equals negative cosine of x. And you get negative, well, you get tangent of x equals negative 1. That's one double check that one just to make sure. Really being careful here. Cosine goes to negative sine goes to cosine goes to negative sine goes to negative cosine. Yeah, that makes sense. So x would be 3 pi over 4. Yeah, because on a unit circle, the slope is negative 1. That's the one that tangent. I mean, that works. Oh, there's two options though. Ah, shoot. Okay, fine. That one and x is 7 pi over 4. Sine diagram. 3 pi over 4, 7 pi over 4. Okay, we're going to plug into f double prime, right? So if you plug in something like 0, you get negative sine of 0 minus cosine of 0. That's negative, then you must change each one. I'm like 99% sure it changes. I didn't check that, but it'll change. So it looks like it's the first one. Negative to positive. Yeah, I think it's pi over 4. Sorry, 3 pi over 4. Yeah. Also, you can kind of imagine what that would look like. And that's sine. That's cosine. If you add them together, probably is like that like it changes from concave down to concave up pretty fast. So yeah, it'd be the first time. So 3 pi over 4, as opposed to 7 pi over 4. All right, that is the non-calculator section. Do I want to actually check my answers on these? I think I do. This might be a good time in the video if you're watching it to skip, but I'm going to write down my answers and just confirm if there's any mistakes. I probably made at least one mistake. I did it extremely fast. D, B, 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 D, A, C, C, D, D. So what I'm doing right now is I'm just writing it down in a notepad document, and I'm going to check on the answer key. D, E, E, A, C, and then D. Oops, where'd it go? Okay, that was D, B, 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 D, A, E, B, A, C, and then E, D, B. I'm going to check these on the answer key, which is at the bottom, I think. Yeah, here we go. Okay, how many mistakes did I make? I already made one, that's not good. Okay. So it looks like 4 was wrong. 6 was wrong. It's too fast apparently. A, C, C, D. Oh man, 10 was wrong too. Man, I got a lot of mistakes. 4, 6, 10. D, E, E, A, C. D, B, B, D. A, E, B, A, C. E, D, B. Well, okay, I missed 3. 4, 6, and 10. Not horrendous for that speed. Let's double check what silly mistakes I made. It's a good time to realize what like how you made mistakes. So okay, apparently I did this one wrong. Let's just go through it more slowly. Line tangent to the graph. Let's see which. Yeah, it was not B. Okay. Line tangent to the graph of x squared. So this is incorrect. Let's do it again. So 2x minus 3 times x dy dx plus y equals 0. Pretty confident about that one. Then 2 times 1 minus 3 times 1 times dy dx minus 3. Yeah, negative, huh? Should be negative. That's really sad. Okay. And then, yeah, okay, fine. 2 minus 3 dy dx plus 9 is 0. And you get, you should get 11 over 3e, I think. So that's my revised one. I will check that in a second. Let me just double check one more time. 9, negative 3, subtract 2, subtract 9, negative 11. Yeah, I'm with the e. Basically, the idea is now that the constants will be different. You'll get 11 over 3. Okay, and then I missed 6. Ooh, whoa, what the heck? How do I do that? I made some silly mistake here as well. I just completely forgot to chain rule. Oh my god. It's so bad. Okay, let's do this more carefully with the u sub. U is 5 minus 3. X, this is like the better way to do it. Yeah, I just completely whiffed this u sub. And this, this is not the antiderivative, right? Because if you differentiate this, you can pick up a 3. So u is negative 3x dx, negative 3 dx. And then you would sub in, and you would get negative 1/3. You got to plug in now. This is kind of why I didn't want to plug in, but 5 minus 3x is negative 1, and then 5 minus 12 is negative 7 of 1 over u to u. That's going to be negative 1/3, a natural log of u from absolute value of u from negative 1 to 7. And that's negative 1/3 times ln of absolute value of 7, which is 7, minus ln of 1. And so you get negative ln 7 over 3. This one. And then the last mistake I made was on which one? 10. Probably just integrated this incorrectly. Okay, let's double check. Particles at position x equals negative 2 at time. It's a negative 2. That's so annoying. Yeah, sign error there, right? So it's actually going to be 13. Okay. So 2 sign errors and a just careless u sub thing. Sad. Let's make sure let's make sure these corrections are correct. Okay, it should be E, B, and A for 4. Let's go down again and see. Oops, where is it? Okay, let's see. 4 should have been E, good. 6 should have been B, good. 10 should have been A, good. Okay, yeah. Yep, sign errors, always gotta look out for them. If I were more careful, I would, know that and go back through and like check my sign errors. But let's go on to the non-calculator section. Sorry, to the calculator section. Where does it start? All right, I gotta pull out my calculator for this one. Yeah, I'm gonna make sure this is visible. Is this the right one? Yeah, there we go. Cool. So the graph of the function f is shown above, semicircle defined by, well, I guess I should only use my calculator when I need to. What's g of 5? Notice 0 to x. So g of 5 would be the integral from 0 to 5 of ft dt. So this area here is going to be 1.5, 3 halves, right? And this semicircle radius 2. So pi times 2 squared is 4 pi for the whole circle, divided by 2 pi. Looks like d. 77, the volume of a sphere is decreasing at a constant rate. This is a related rates problem, cool. So it's decreasing at a constant rate, that means dv dt is a -3, and with an instant when the rate sphere is decreasing, okay, so they're telling us, so that find the rate. Oh, interesting. They don't ask that very much. Find r when dr dt is 0.25. That is valid. So you take this equation. V is 4/3 pi r cubed. Differentiate with respect to t. So get dv dt is 4 pi r squared dr dt. And then you, let's see. Okay. And we know dv dt is, so we get -3 equals 4 pi r squared times 0.25, which is a quarter. Let's cancel. So you get oh, sorry, decreasing at a rate. It makes more sense. Okay, negative. Cool. I was wondering why I was getting a square that was a negative. So the negatives cancel. So you get 3 over pi is r squared. So r should be root 3 over pi. Not plus or minus because it's a radius. And my calculator says root 3 over pi is 0.977. Okay. Hopefully my calculator's not covering everything. Okay, that's good. All right, 78. Let f and g be continuous. Functions, okay. What's the value of that difference? Well, this is pretty... Yeah, this is pretty silly. Okay, so the idea is, what do we know? We know 0 to 10 of f, 0 to 10 of g, or 0 to 10 of 1/2 g. That means 0 to 10 of g is going to be 16. And that means 0 to 10 of f minus g is 21 minus 16, which is 5. And then that is going to be equal to, so we have 5 equals integral 0 to 10, which is the integral 0 to 3 plus the integral 3 to 10, which is integral 0 to 3 plus 2, because it tells me that's 2. So 3? Yeah, 5 equals integral 0 to 3 plus 2. I know I'm doing a lot of annoying shorthand here, but 3 is integral 0 to 3. I think that makes sense. If I add that to that one, you get 5, and 5 is legitimately like the difference. Yeah, okay. 79, the figure above shows f prime, which could be the graph of f. So from f prime, it needs to be needs a 0 there and a 0 there, 2 and 3. So not a, there's no 0 derivative of 2. So b is still in the running, c is in the running, d is in the running. Okay. Now I gotta check about increasing. Yeah, so so f should be increasing when f prime is positive. So it should be increasing from 0 to 2 and decreasing from 2 to 3. That's the idea. So B's out because it's not increasing up to 2. I need to look at E. C is increasing up to 2. That's fine. E's out because not increasing up to 2. So C or D is still left. Should be decreasing from 2 to 3. That looks good. Increasing from 3 to 4. Oh, this all look good. What's the difference between C and D I can notice? It looks like I should be tapering off here at 4. There should be a flat line. But that looks accurate. Yeah, I'm going to go with C. So, not D. C. Alright, 80. For time t greater than 2, the position of a particle traveling along a line is given by a different function. Fs is increasing. That means v prime is positive on 0 to 2. And then v prime is negative on 2 to infinity or whatever, on 2 to 5 at least. So to find the total distance traveled, you need to integrate 0 to 5, right? Okay, of absolute value v. That's going to be 0 to 2. You can break it up this way, absolute value v plus integral 2 to 5 absolute value v. But on 0 to 2, absolute value v is v, because v is positive, not v prime, sorry, just v. And this will be negative, because absolute value v is negative v when v is negative. Kind of weird. That's how it works. So integral 0 to v minus integral 2 to 5 v. But v is s prime. That looks like C. Wait, no it's not. Okay, it's just E. I should have looked at E. I mean, literally it's just the integral of the absolute value, so I guess it's kind of mean, really. I thought it'd be A to C. But okay, it's just E. Notice D and E are slightly different, and D is actually wrong. Yeah, the absolute value of the integral is not the integral of the absolute value. Just double checking this one. This makes sense. Yeah, okay. S is position, right? It must be. Position, yeah, okay, cool. All right, 81, a cup of tea is cooling in a room, has constant temperature, 70 degrees. If the initial temperature is 200 and the temperature changes at that rate, what's the temperature at 4 minutes? That's just the integral. Well, sorry, that's 70 plus the integral from 0 to 4 of r of t dt. So I'm going to pull up my calculator. Just go in your calculator and dump this in. 70 plus math 9, integral 0 to 4, r of t negative 6.89, e to the negative 0.053, x, geez, dx, not times x, dx, like that, to the nearest degree, 45 minutes, everything's in minutes, yeah. All right, looks like 45. Okay. Yeah, this is initial plus change, right? Even though the change is negative, it's okay. 82, the derivative of the function is given by whatever on the interval. When does it have a relative max? You just got to graph this, right? Relative max when this changes from positive to negative. Because that means f is changing from increasing to decreasing, which is a max at the top there. So just graph and figure out when it's a positive and negative. Notice this kind of tells us what our window should be. So let me show my calculator again. So we're going to get into y equals, clear it out. X cubed. Remember, this is f prime, so it's fine. X squared plus 1. Okay, graph it on probably negative 3 to 3 is a reasonable window. And let's go negative 5 to 5. Okay, we got that's a negative to positive there. We got a positive to negative only at one point, so let's just calc intersect that. No, I guess 0 that. Left bound here, right bound here, guess, just put on top. Okay, 0.5423. Is that an answer? Yeah. Cool. The table above gives selected values for a continuous function f. If f is increasing over the closed interval 0 to 3, which of the following could be the values of integral 0 to 3? Oh, yeah, okay, this one's annoying. They're really not telling you, but the idea is you're going to approximate this using left and right Riemann sum. And this will need to be between those. Why? Because for an increasing function, left Riemann sum is less than the integral because it goes underneath. And for a right Riemann sum, it's going to be positive, it's over it. So you got to be bounded between these two. Luckily, the gap is consistent. So for left Riemann sum, you can go 0 plus 4 plus 10 plus 18 plus 28 plus 40. I do have a calculator for this, I guess. And don't forget to multiply by 0.5. I'm not going to show one of my work. I'm just adding those. 18 plus 28 plus 40. And then got to multiply by 0.5. So it looks like this is, the LRS is 50. And then the right Riemann sum is going to be 77. And so it's got to be that one. Cool. And it's strictly less than. Because, well, depends on their definition of increasing, I guess. I'll believe them that they mean strictly increasing. Okay. Next one, the graph of function f is shown in the figure above, which of the following statements is true. F of a is 2. No, it's 1. F is continuous at a. No, it jumps. So, the limit is 1. No, the limit's 2. That's what the whole is. Limit is 2. Yes. Limit doesn't exist. No, it's d. Okay, 85, particle moves along. What's the velocity at the first instant the particle is at the origin? So you got to figure out when this is 0. That's the origin. So you need to solve x of t hat equals 0, and then find x prime of t hat. So just graph it. Okay, here we go. Cosine of root t. Yeah, okay, cool. And then graph this. I probably should have made a window different, but I think it's good enough. It goes across there. 0. Let's just go there. Right bound is take forever. There, I guess. Around there, I guess. 2.4674. I think you can just do calc. Oops. Not what I wanted. That. Okay, found the root. And calc dy dx. We'll do it. It really won't, huh? That's so sad. Okay, fine. The right way to do this is to find the 0. Oh my gosh, come on. There's a 0, quit out, x has a 0 in it. Now you just do math 8 dy dx of y1 at this value. Cool. Okay, let's see. Okay, 86. So it's increasing and concave down. F is increasing and concave down. Well, here F's not increasing. Here too. Okay, so C, D, or E. This one's a straight line, so it's not concave down, so that's not it. Now to check concave down, right, you get like, technically get like MVT, it's really annoying. Like, the average rate of change here is 1, the average rate of change is 2. So there is a point between 0 and 1 where the derivative is 1, and there is a point where the derivative is 2. And so you can use MVT again with those, and you get a positive number. but it should have been negative, so D is out, and E is correct. Maybe you can just like graph these. Like E kind of looks right. It goes 4, 6, 4, and then 6, and then 7, like that. That looks like a concave down function. The other ones are like this kind of. That looks like concave up. 87, let f be the function of the first derivative given by whatever. How many relative extrema does f have? Okay, just graph and count the number of crossing points. So let's graph this. Three minus 2x minus x squared. Oops. Sine of 2x minus 3. Negative 42 tells me my window. That's 1. That's not 1. That's 2. That's 3. That's 4. That's 5. That one is a 0. Let's just double check that legitimately is a 0. Let's zoom in on that one. Well, okay. Actually, the cheaty way to do this is like, if it went a little bit above, it would cross twice and you'd say 7. So 1, 2, 3, 4, 5. It gotta be 5. Okay. Oh, although I should be careful with my window. 1 second. Negative 4 to 2. That first one was a lie. That was bad of me. I almost got caught by that. So 1, 2, 3, 4. It could be 6 now, right? Okay, I need to zoom in around this point just to check. Oh, those jerks. Yeah, it's 6. I think. That's probably why they get that question. It's relative extrema, right? Okay. 88. Okay, so we're comparing f prime 0, f prime negative 1, f prime 1. That one's 0, flat line, right? This is f. F prime of 0 is positive. And then f prime of 1 is negative. So it should go f prime 1, f prime negative 1, f prime 0, d. 88. What is the volume of the solid? Okay, x equals 0, y equals 5. Root y minus 2. That one's really annoying. Just solve this. Oh, we're going around the y-axis. I guess I shouldn't. Yeah, so it's going to be root y minus 2. Normally that would be like this. I got to rotate. I got to flip it so it looks like that, I think. Yeah, that would make sense. Okay. This is obviously 5. This is your blank comma 5. I don't care. This one is blank comma 2. So I should be doing the integral from 2 to 5 of root y minus 2 squared pi. Yep. Okay. Of course, the calculator doesn't. Of course, it doesn't matter what you name the variable. So I'll just do it with x in my calculator. So math 9, 0, 2 to 5 of square root x minus 2 squared. I probably could have done that by hand now that I think about it, but whatever. And then times pi. Okay. Hopefully that's right. I am going through pretty fast. I'm probably making mistakes, but another way to do this is like just ignore this like y variation. Just do y equals root x minus 2 and revolve around the x-axis. That'll be the same. 90. The population of P. How many more are there? Oh, a good amount more. The population of P of a city grows according to the difference equation. Whatever. Okay. Once you see this, you're just supposed to know that P is C e to the KP, the KT. Not very hard to derive that though. dP over P is K dt. And you integrate and you get natural log of P equals KT plus C. Exponentiate. Standard thing. And then you're absorbing the plus minus into the C. Okay, population doubles every 12 years. So that's like one thing you can say is that p of 12 is 2p of 0. It's like a pre-calc problem. Right, so we get c e to the 12k equals 2c. And let's see, we can divide off the c's. So e is going to be, sorry, natural log on both sides. 12k is natural log 2. So k is ln 2 over 12. Calculator says 0.0577. Yep, 91. Okay, this is annoying. This is a u sub. U is x squared minus 1. Du is 2x dx. So you get 1/2 integral 1 squared minus 1 is 0. 3 squared minus 1 is 8 of f of u du. And right, the 1/2 comes from this 2 dividing off. Okay, let's see. Oh, but that's 6 though. Oh, 3, awesome. Continuity is important for, I guess, u sub. Is that right? I should know that more clearly. 1/2 times 6, sorry, which is 3. Okay, one more. 92, the function f is defined for all x in the closed interval. If f does not attain a max value, this is about EVT. If x is continuous, EVT would force you to have a max value. So f's not continuous. All right, yeah, bounded doesn't matter. You might think like, well, I mean, if you don't have a max value, not bounded, right? No, you can do this. No max value, strangely enough. F does not attain a min. Well, it certainly could. The graph f is ever no. Right? There's no reason f needs to be differential at all. It could be differential nowhere. Okay. And let's check my answers. Start at 76. I feel like I made a lot of mistakes. I'm like more tired and going faster. Okay, I'm just gonna record these. 76 starts off with D, and then I said E, A, C, E, and then 81 is, I said was E, E again. Wait, I skipped one. 81, 82, yeah, okay, and then B, 84, what I said was D, and then C, and then I said E, E, D, E, A, and then B, A. Okay, I'm going to check those. And then if you look at FRQs first. All right, 76. How many mistakes did I make? DACE, good. Looks like 81 was a problem. Okay. AEBDC, okay. EEDEA, okay. BA. Oh, only one mistake. Not too bad. So question 81. Okay, let's go back up there. Oh, really? Oh, shoot. I just didn't read it closely enough, did I? Yeah, I said 70 plus. Let's see. Yeah, I said 70 plus, but that's the constant temperature of the room. It should have started at 200, so it should have been 130 more than this. So 175 should have been A. And let's just check that. Yeah, read the question more carefully. Surprise, surprise. You do things wrong when you don't read it. 81 was, oh, here we go. Yeah, it was A. Okay, not too bad. All right, I think I will stop there. I think only one person's watching this time. Well, thank you for coming, and I'll upload this to YouTube, I think. All right, happy studying. Have a good one.